Hello guys and welcome back to my channel Interview with Bunny, and we are back with another video on system designing playlist. And the topic or the system that we will be designing today is one of the most requested topic in my YouTube channel, and that is the payment gateway. But before proceeding or before starting with the designing of the payment gateway, we have to know some of the basic things about the payment, because this payment thing is a huge topic to discuss, and it is not possible for a person who is not from this background to know each and every flow or each and every pattern of the payments. So before proceeding into this payment domain, or before we start with designing this payment gateway, I will give you some of the important things that is actually needed to design this system. So the first and the foremost thing that you need to know before designing this is what is the difference between a payment gateway and the payment processor. Because unless and until you do not know the exact definition of the payment gateway and the payment processor, you will set a wrong expectation from this video, as well as during your interview. If you face this question, at that time you won't be able to gather the functional or the non-functional requirement clearly. So let's start with the first topic or the first knowledge that you need to know, and that is the difference between a payment gateway and a payment processor. So here, if you look carefully, these are the two definitions of the payment gateway and the payment processor. Let's understand it first. So a payment gateway is a platform that collects payment details from the user, secure and tokenize them, and then orchestrate the transaction flow and communicate with the payment processor. I know you are not clear with what it actually means. I will tell you very soon. Whereas in case of the payment processor, a payment processor is a financial network entity that actually talks to the bank and the card network to authorize, capture and settle the money. So basically what actually happens, the entity or the system who actually does the real transaction with the bank, who actually talks with the bank, is nothing but the payment processor. Whereas a payment gateway is an orchestration engine which actually captures the user data, for example the card number, CVV number and all these things, and thereafter it secures and tokenizes, and once it tokenizes everything, it sends that token or the packet to different payment processor as required. So that is the main difference between the payment gateway and the payment processor. So here in this video also, we will be discussing the payment gateway. We are not dealing with how the money is getting debited or credited from the bank and all those things. I hope right now you got the idea that how the payment gateway and the payment processor actually differs among themselves. So here in a simple word, a payment gateway is a traffic controller of the payments, whereas a payment processor is the system that actually moves the money. Clear? Now since you got the idea of what is a payment gateway and the payment processor, now let's start with the first step of our designing, and that is the gathering of the functional requirement. But before that, I just want to tell you, since designing of this payment gateway is very much domain centric, means until and unless you do not have a thorough knowledge of the payment, you cannot basically design this system. So in general, do not expect this question during your interview, because in most of the cases, it is not expected that a candidate who is not from a payment background will know all these things. But in case you face it, obviously you do not have any other way than to solve this problem. So let's start with this design. So the first and the foremost thing that we will be doing, and that is the gathering of the functional requirement. So the first and the foremost requirement that we have to fulfill over here is number one, the client should be able to make a payment intent in our system. So as I already told you, since this thing is totally a domain related thing, obviously the requirement will be also a domain centric. It won't be a simple non-technical functional requirement that we have done in our previous video. Rather, it will be a very much technical functional requirement that we have to solve. And one more thing, I am also not from a payment background. I have to do a thorough research on this topic for the last 1 or 2 weeks, and thereafter I have came up with this designing. It might happen that I will miss some of the point or some of the flow over here, but more or less I have covered in detail, and it is sufficient enough to clear any technical interview. And if I have forgot to mention any of the point or mention any flow, feel free to let me know in the comment section. So let's start with the first requirement, and that is client should be able to make a payment intent request. Number two, the gateway environment, that is what we are developing, should create a temporary session page by which the user will be giving the card details. So as you know, when we do a payment, when we click on buy now, there is a page that gets reload, or there is a page that comes up in the website where you have to give all the card details and everything. For example, you have to select the credit card, and based on that you have to give the credit card number, CVV, and all those details. So that is actually a page that is given by the payment gateway. It is not that Amazon or Flipkart is creating that page. So this is a page that we have to develop and we have to give to our client so that the user of that client can enter the card credentials. Clear? Number three, we have to securely handle the PCI complaints data. Now, what is a PCI complaint? Let me tell you that too. So a PCI DSS data is a global security standard for all the entities that stores, process, or transmit the cardholder data or the sensitive authentication data. So obviously, whenever you are giving the card details into a particular website, as I was discussing earlier, there, after capturing all those information, there is a secure protocol that we have to follow, or there are some PCI standard that we have to follow so that we can save that information in our database, and also we can move forward to the payment processor. And that is why here we have to maintain a secure ecosystem so that the PCI standard is maintained. So securing the transaction is very much critical in this payment ecosystem. Number four, once the transaction is done or it is successful, we should be able to give the transaction status to our client. Clear? So these are the four most important functional requirements that we will be solving over here. So as I was discussing, these are the four functional requirements that we have to solve for the payment gateway. I hope this is clear that what are the use case or what are the functional requirements we are trying to solve over here. Now, one more thing I want to tell you, that there are few of the things that we are taking out of scope. Number one, a part payment. Number two, the refund or the return of the payment. So I will just mention it as the out of scope over here. And that's it. These are all the functional requirements that we have to solve in this problem. Now, since you have understood that what are the functional requirements we are going to solve over here, and you are somehow clear with what is a PCI data and what is this temporary session thing, now let's go to the next step, and that is the gathering of the non-functional requirement. But believe me, if you are not clear till now that what all these things are, do not worry. At the end of this video, you will be 100% clear with what each and everything meant and what you actually need to solve this problem. Now let's go to the next part, and that is the gathering of the non-functional requirement. So as you know, the first non-functional requirement that we have to solve is we have to get the estimation that what is the scale of the system for which we are designing this system. So here, if you ask your interviewer that what is the scale of the system, he will be telling that we will be handling a 10,000 requests per second. So that is the 10K TPS over here, means that is the 10,000 transaction per second. So this is the scale that we are targeting. So obviously, since it is a gateway which is communicating with multiple processors, so obviously the volume of the data will be quite huge. Number two, the most important, that is the cap theorem. And as you know, the cap theorem tells that whenever you are creating a distributed system, you either have to compromise between the availability or the consistency of the system. A particular module of the system cannot be highly consistent or highly available at the same time. But here, in case of the payment gateway, as you all know, our system should be highly consistent, because here we are dealing with the payment transaction. It does not mean your system should be down for some time, but it should not get the priority over consistency. So here you can see I have given the priority of the consistency more than the availability. Now the next important thing is like the latency of the system. And whenever you are talking about the latency of a payment gateway, the latency should be as nominal as possible. And whenever we are telling that as nominal, means we have to quantify it. And so here what we will do, we will tell that our transaction should get completed within 200 milliseconds. So that is the amount of latency that we are targeting over here. So here if you just look carefully, I have mentioned it clearly that it should be below 200 millisecond response time for the payment authorization. That is because I have already told you a payment gateway does not do the transaction with the bank. So whatever our responsibility, that is the tokenization and the authentication, that we should complete it within 200 milliseconds. Thereafter, we will orchestrate that token to our downstream, that is to the processor, and it will take its own time. But the logic of tokenization and validation should be done within this 200 milliseconds. Clear? Now comes the last and the main thing, and that is the security of the system. And whenever I'm telling security, it means that our system should be a PCI DSS complaint system. Clear? So these are almost all the non-functional requirements that we have to solve for this problem statement. So here if you look carefully, we have almost gathered all the functional and the non-functional requirement that we have to solve over here. I know it is quite a high level requirement right now and you might not be familiar with all the use cases. But as I have already told you, do not worry, you will get to know very soon. Now let's go to our second step of our designing, and that is the identification of the core entity. So let's first identify that what are the core entities that we can assume or we can identify as of now just by reading all the functional requirements. So here if you look carefully, these are all the core entities that we can find out over here. Let's go through this one by one. So the first one is the merchant or the client. So here with respect to our system, let's first understand that what is a merchant or a client. So for example, we have created a payment gateway, and for us, the client is nothing but the business who have integrated us. Means the Amazon, Flipkart, Walmart or whatsoever online platform who is doing the business, that is nothing but our merchant or our client. The next core entity is the transaction, means the actual payments that is happening by our system. Number 3, the payment method. Why payment method is important? So obviously whenever a user is doing a payment, he or she have to select that whether he have to do it with the help of a Visa card, whether he is using a MasterCard. So the payment method is important over here, and that is why this will become our core entity. Number 4 is very obvious. That is the user of the customer, which is nothing but the users of this merchant and the client who is actually giving the payment details. Number 5 is the webhook, means whenever you are making a transaction, you will be seeing that once you are done with the payment page actually loads and comes to the failure or the success page. That is nothing but a callback that gets generated when you submit some event to the payment gateway. And that is why this webhook is necessary, by which we will be giving our client the success or the failure message from our system. Clear? And the last but not the least is the payment session. And in this system, a session for the payment is very, very critical, because whatever happens for a particular transaction depends on the session. If your session gets invalidated or we cannot authenticate your session with the payment that you are making, your payment will definitely get failed. So the session management of this ecosystem is very, very critical. So this will be another core entities for our system. I hope you are clear with that what are the core entities that we have identified as of now. It might happen and it will happen that there will be few more entities that you will come across at the future. But as of now, just by reading this functional requirement, these are more or less all the core entities that we have to list down. Clear? Now let's go to the third step of our designing, and that is the API designing. Now before going into the API designing, I have to tell you few of the other things, because obviously I assume that you are not familiar with the payment ecosystem and you do not have any prior knowledge that how a particular transaction takes place when you click on buy now. That is why obviously it is impossible for you to develop that what are the relevant API endpoints that you have to list down over here. So before going into the API designing, what I will do, I will just give you a small idea that what are the steps that are actually involved when you initiate a payment, because without knowing that it is impossible to design the APIs. So let's first understand that what actually happens when you click on the buy now. So what actually happens is, like, whenever you click on buy now, a payment intent gets generated in the system. Means, for example, here we are having two things. Number one, This is our client, which is nothing but our Amazon or the Flipkart. And let's take an example. This is our ecosystem, that is the payment gateway. Now what happens once a user clicks on buy now, a payment intent request first comes to this payment gateway. Means a buyer wants to make a payment. So this will be our first step called as the payment intent. Now, once the payment gateway means the system that we are developing, once we receive a payment intent from our client, what we actually do or what we have to do, we have to save this information in our backend. Means a user want to make a payment, and in the response, what we will do, we will send a payment intent ID to the client. Clear? So in the response of this API call, we are giving a payment intent ID. So what happens is like whenever we get a payment intent from the client, the first thing what we do, we save all this information, means what is the item that he want to purchase or what is the price of the item and all this information in our local database. And in return to that, we send a payment intent ID in the response. And once the client receives this payment intent ID, what they have to do, it have to first secure the session, means a payment is going to happen. So from now, create a session by which this entire payment transaction should happen. So another request will come from the client to our payment gateway, and that is for the generation of a session. Means here what the client is telling that the user want to make a payment, and that is why create a session or create an environment for the user by which the user can be able to make the transaction with the bank. So here the second request will be the session management or the payment session. So these are the first two steps that will happen with the client and the payment gateway. Now, once we see that the client want to secure a session or want to establish a session request over here, what we have to do in the request or in the callback, we will give a session or a temporary web page to the client, which actually looks like a page where you can fulfill all your bank credentials. So as you know, once you click on buy now, after a millisecond or so, you land on a page where all the card details appear, where you can put all the card credential and everything. And that web page is actually created by this payment gateway, and that have a session timeout. Means if the session timeout expired, you will not be able to fulfill the payment. So as you know, whenever you are trying to buy something, you will see that at the corner or somewhere, you will be seeing a stopwatch that is going on. That is nothing but the timeout of that session. Clear? So once the client makes a request for the session, what we have to do in the return from the payment gateway, we will give an HTML page or a front end where the user can enter all the required credentials. Clear? Now once the user enters all the credentials of the card, what it does, it clicks on the pay now. That is the final step of the payment. And at that time, a pay request comes to the payment gateway. Means all the credential of the card is given by the user. Now it is the responsibility of the payment gateway to tokenize it, to manage it, and pass it to the processor by some method. So these are actually the three steps that are involved when you actually make a payment transaction. I hope right now you are clear with what are the three steps that are involved when you are making a payment. And these are the three main endpoints that you have to expose for your clients so that the payment can be made successfully. So let's now list down all the API endpoints that you need to fulfill all our functional requirements. So here you can see I have listed down all the endpoints or the API REST endpoint that are needed to fulfill our functional requirement. That is the generation of the payment intent, the generation of the payment session, and the actual request to make the payment. And the last but not the least, you can see here we have taken a functional requirement that is our platform should facilitate the transaction tracking system. Means whatever the transaction that had happened, we should be able to show the status of the transaction, and that is why here this is a GET request. I hope it is clear that what are the API endpoints that we have to design over here. Now since we have almost completed the three major steps, that is the gathering of the functional and the non-functional requirement, the identification of the core entity and the API designing, let's now go into the next step of our designing, and that is the high-level designing of our system, where we will list down all the major components that are needed to fulfill all this functional requirement. So let's go to the fourth step of our designing, that is the high level designing of the payment gateway. So the high level designing of the payment gateway is actually quite simple if you have understood the things that I have told earlier, that is how the actual payments happens over here. So let's draw it one by one so that it will be easy for you to understand. So the first and the foremost thing that we have to introduce are the clients for our system, who are nothing but the big organization or the merchant who are actually making the payment. So here we will be having our first component, and that is the client or the merchant. I hope this is clear, and obviously this client and merchant should be also interacting with the user. So which is obviously not our part of the designing, but we will just mention it that there are a few users who are actually dealing with this client or with this merchant, because they are the actual entity who will be giving the card details. So here there will be some flows from the user to the client or the merchant. I hope this is clear as of now. Now here, since we are creating a system which support 10,000 transactions per second, and we have different functionality of tokenization and everything to fulfill, so obviously our backend should follow the microservice architecture. Clear? And whenever we are going with a microservice architecture, obviously we need a load balancer and API gateway to route our traffic uniformly. And that is why here we will be introducing our second component, and that is the API gateway and the load balancer. I hope this is clear as of now. This is quite a straightforward approach. Now starts the main thing, that is how the transaction will happen. So as I was discussing while doing the API designing, what happens at the first step of our transaction, that is once the user clicks on buy now, a payment intent request comes to our server. That is from this merchant or the client, our request will be coming into our server called as a payment intent request. And obviously to handle the payment request, we need a microservice over here. And that is why here we will be introducing a service called as the payment intent service. And what it actually does, once it receives the payment request, it capture or store all the payment related metadata into our backend database. Means which is the item the user want to buy, what is the amount that need to be deducted, what is the currency, and all this metadata of the payment should be captured by this payment intent service. Keep in mind, it is not capturing the card details. It is not the responsibility of the payment intent service to get the card details or any sensitive data. So what we will do, we will be using a database over here to capture all this data. So here we will be introducing a database. Maybe we can call this a payment intent DB. I hope this is clear. And as I was telling you, once this payment intent is saved into our database, what we do, we give a response to our client, that is the payment intent ID. And once the client or the merchant receive the payment intent ID, it makes a second call into the gateway, and that is for the creation of a session. So the next call that comes to us is regarding the creation of the session, which involves the payment intent ID that it have given in the response, as well as the transaction ID and all those things. So here we will be introducing our next microservice, and that is called the payment session service. Now once this payment session service receives the request, what it actually does in the backend, it creates a session for the payment, and in return it gives a secure web page to the client by which the user can enter the card credential. So what it does, in the response to this request, it gives a secure checkout web page. Clear? I hope this is clear. So all the details of the card should be entered by the user in the web page that we, the payment gateway, is sending. It is not that this merchant will create his own web page and get all the card details, because that will be a very insecure way to get all the card details. And if the client does it without doing the PCI complaint, it will go into a very big security concern. So what happens to gather all the card information? We, the payment gateway, gives a web page in the session management. And once the user get that web page, what they do, they obviously put all the information of their card detail and clicks on pay. And once it clicks on the pay, another request comes to our API gateway, that is a payment now need to be done with the bank. And thus what we do, here we will introduce another service called as a payment processor service. And this payment processor service is actually involved in making the transaction with the payment processor. So here what we will do, here we will introduce another service which is nothing but our external service called as a processor service, which is actually doing the transaction with the bank. So here what we are doing, here with the help of a secure connection, we are calling the processor service. And once this processor is done with the payment with the bank, it sends a response to this payment processor service that a payment order have been placed successfully on the bank. Just to clear one thing, the response that we are getting right now is not the final confirmation that the payment was successful or not. It is just an acknowledgement that a request or the payment order have been placed to the bank. So what actually happens, whenever we are making this call over here, though we are making the transaction with the bank, but the confirmation that we are getting in the response is not the confirmation that the money got deducted. So in some of the scenario, you have seen that while we are making a transaction in the UI, we sometimes see that our payment got failed, but somehow in the SMS we get that money got deducted in the bank. Similarly, it can also happen that once you click on pay, the actual payment did not take place, but the order got placed successfully with the message that the payment was successful. But after a few days or after a few hours, you can see in the order list that your payment got declined and it will ask for another payment retry. And this actual scenario is done with the help of the reconciliation, with the help of the payment processor and the payment gateway that we have developed over here. I will explain all these things in detail when we will be going into our next step, that how we should handle all the scenario of the failure, because obviously since these things are all related to money, we should be 100% secure and 100% confirmed that a payment got success or failed. So to implement all these things, there should be a strong reconciliation job that should run in the backend to validate all the session ID, intent ID, payment ID and all those things, and at the end of the day or the end of the hour, it will give the response that the payment was success or failed. So here if you look carefully, this is what the high level designing of the payment gateway looks like. So here if you see, I have tried to cover more or less all the core entities that are needed to make the payment. But believe me, this is actually not at all simple the way it looks like. And this designing is not even 1% that what we will be doing in our next step of our designing, and that is the deep dive of our designing, where we will design in detail of each and every component, where we will see that how each and everything will secure the data, how we should parse the data, validate the data, and how we should encrypt the data, and how each and every component will interact. So without wasting much time, and since you got a brief understanding of how the transaction is done in our payment gateway, let's move to our fifth step of our designing, and that is the deep dive designing of the system. Before proceeding further, I just wanted to notify that I have created a very simple website over here so that you get all the contents that I upload on the YouTube on a single platform. So here you can see there are lots of content on the system designing, on the low level system designing. Similarly, here we have the complete graph playlist where we have already 15 to 16 video over here, as well as all the latest contents that I'm uploading on the YouTube. I will keep on updating all those things in this website. This is a free website that is hosted also in a free domain. So do not forget to bookmark this website so that it will be helpful for you to find out all the relevant contents regarding your upcoming interview. So let's start with the deep dive design. So the first thing that I will do, I will copy this entire high level design and I will paste it in our deep dive design. And let's start with our first component of our system, and that is the payment intent service. So till now, this flow will remain the same. That is, here we have the user and here we are having the merchant who have actually onboarded our payment gateway. And as you know, since we are using the microservice architecture, so obviously we will be having the API gateway and the load balancer at the very beginning, which have the general responsibility like authentication and authorization, routing of the traffic and load balancing. So all those flow will remain the same as we have discussed in our earlier video. Now let's go into the first component, and that is the payment intent service. So as we have already discussed, what the responsibility of this payment intent service, that is once the user clicks on buy now, a payment request, a payment intent request comes into our application, and that request is being handled by this payment intent service. Clear? Now, as soon as this request comes over here, we capture the metadata in our payment intent DB. Now let's see what type of database we should choose and what will be the schema structure over here. So as you already know, since we are dealing with the payments and we have already told that our system should be highly consistent rather than availability, so obviously we will be going with a consistent database. And whenever we are telling a consistent database means we should go with the relational database. And whenever we are telling about the relational database, it should be a Postgres solution or it should be a MySQL solution. So here we will be going with the Postgres solution, and let me show you how the schema structure will look like. So this will be more or less the schema structure of the payment intent DB. So let's first check it out. So here what we are doing, here once the request is coming from our client or from our merchant, we are creating a payment intent ID. This is an auto-generated ID that we are creating in our system. After that, we are capturing the amount, currency, the merchant ID, the customer ID, the order ID, the payment method type, and all these things. So there will be plenty more metadata that we have to capture right now to validate the order in our later phase of the design. So these are more or less all the data that we need to capture over here. And once we have created an entry for our payment intent, what we will do here in the response of this request, we will simply return this payment intent ID. Clear? So I will just write it over here that the response for this request will be the payment intent ID that we are generating in this request. And that's it. This is the only thing that you have to describe for the payment intent service. Clear? Now, once the user or the merchant receive this payment intent ID, what is the next step? We have to create a session or create an environment by which the payment can be made. So the next request or the next API endpoint that gets called is nothing but the request to create a session. So here if you have seen, we have black box this entire implementation over here in our high level designing. But here in this deep dive designing, we will see each and every component that is required to create this checkout web page or how we will do all these things. So what I will do, I will just get rid of this service and I will rename it to something meaningful. So I will name it as a checkout session service. Means it is creating a session for our checkout page. Clear? So the request is coming into our checkout session service. Now what is happening here, from this service, we have to return a web page for our front end. And how we actually do it, the first thing that we do is we submit or we save this information into some storage unit. So actually what we do, once we receive the payment intent ID in our previous call, in the second call that is in our session creation service, there also we send the payment intent ID in the request, as well as we send all the other metadata like the transaction ID, the user ID, the order ID, and all the meaningful data into our system. And what we do, since here we are initiating a payment from the payment gateway side, so we first create or capture all this data in our database. And here if you look carefully or understand the system carefully, all this session that we are creating for a particular payment is a very short-lived process. Means a particular session will be maximum to maximum active for 10 minutes. So here instead of saving this information into a database, what we do here, we use a Redis cache to store all this information. And one more benefit of doing that is like the retrieval time of this information will be very quick since it is a caching system. And one more thing why we are storing all this information in a Redis cache is because here if you look carefully, we have told that the latency of this system should be as nominal as possible, and it is only possible when we omit the database access and we take the advantage of the Redis cache and all this caching mechanism. So what we will do, the first and the foremost thing, once a request come into this checkout session service, all those metadata that are coming into this request, we will simply store it into our Redis cluster. Clear? So here we will be having Redis cache and here we will save all the information. And once we are done with this operation of writing into the Redis cluster, what we will do in the response of this request, we have to give a web page to the client. Now, obviously, we are not giving a complete web page. Rather, what we will do, we will give a generated URL of the web page, means our payment gateway web page, where all the credentials of the debit card and the credit card will be inserted by the user. So let me just tell you how it is done. After that, it will be clear to you. So what we will do here, if you look carefully, this is how the response of this checkout session service will look like. So here we will be returning a session ID which we are creating over here, as well as we will be giving a web page or a redirected URL of that web page. So how it will look like? So for example, it is a payment gateway domain ID followed by the session ID for which this response have been generated. So for example, there is a request that came into our session creation service. Now what we are doing, we are saving all the information in the Redis cluster, as well as we are generating a session ID for that request. For example, this is your session ID, and once we have generated the session ID, in the response to this request, we are creating a redirect URL of a particular web page which also belongs to us, but the URL of that web page will look something like this. So this is our URL followed by the session ID that we have generated over here. So this is how the response will look like. Now the next question is obviously why we are sending the session ID as a parameter. This is totally because of the future authentication of the system. So for example, a particular client changed this session ID over here. So at that time, once the next request of the pay comes into our system, we will first validate that the pay request, whether it matches with the session ID that we have kept in our Redis or not. And if it doesn't match, we will invalidate that request. And if it matches, then we will proceed with the payment activity. So here, to validate that or to validate a particular request, we are sending the session ID in the parameter. Clear? So this is how the response for the checkout session service will look like. Now, once the user receives this URL, what they will do, since this is a redirect call, so obviously the client or the merchant have to redirect their web page into this URL. And that is why from now, if you just do a payment in any of the website, you will see that once you click on buy now, there will be a small refresh that happens, and thereafter the entire URL on your search bar changes, and then after you land on a payment gateway where you can put down all your credential of the credit card. So this is how this is done. Now, who will create this web page? Obviously, we have to do it. So here what we have to do, we have to create a client-side service which will actually give them the web page. So let me tell you what I actually mean to say. So here we have to introduce one more service that is called the checkout frontend service, which actually creates the HTML page for this following URL. Clear? So here we will be having our next service called as checkout frontend service. So once the client or the merchant actually hits this URL, the actual secure web page where the credential can be given is hosted in this service. So from this checkout service, the request will be coming into our front-end service. Now, if you look carefully, we have taken an assumption that is the scale of the system is 10,000 requests per second. Means 10,000 requests is coming into our checkout payment service for the creation of the session. Now, as the request is coming, we are giving in the response the redirect URL. So obviously all the front end or all the client will receive this redirect URL and will try to open that web page. So here the checkout front end service will also receive those many amount of requests, that is 10,000 requests per second. So here also, instead of directly hitting this service, we have to redirect all this traffic with the help of the load balancer. So what I will do, I will simply create another load balancer which will help to route all our traffic into our checkout front-end service. So this will be another load balancer. Now the question might come that why we are not passing the same request from this API gateway or the load balancer. That is because this is a single request, that is here we do not need an API gateway. Here it is not an API connection. It is simply a front-end ecosystem or a front-end web page that we have to display, and we are having a single server with multiple replication. And that is why here we do not need an API gateway, rather a simple load balancer will be doing. And that is why here we are showing it in the different boxes. So I hope it is clear that how the second step is going to complete. Clear? Now, once the user puts all the details of the credit card and debit card and click on pay, now comes the main thing. That is, we are going into the third step and the final step of the payment when it will hit our actual checkout processor. So the third step begins from here, that the client have entered all the credentials of the credit card and they have clicked on pay. And once the client have clicked on pay, the request will go into our payment processor service. But here also, instead of naming it as a payment processor service, I will name it something different, and that is the checkout backend service, because this service will actually handle whatever the data that we have sent from the front end of this checkout service. So here what I will do, I will simply rename it as a checkout backend service. So the client have clicked on pay. Now all the metadata of the credit card and all the sensitive information of the credit card and all the PCI data have landed into our checkout backend service. So here, if you have understand this architecture clearly, you will get to know one thing, that at nowhere the client or the merchant are having the access of credit card or the debit card, because here at all time, whenever user have given the information of the credit or the debit card, it was within our environment, because here they are using our HTML page where they are inserting the data, and here also they are submitting the data into our backend service. So by nowhere this front end, that is the client or the merchant, can get the sensitive data of the user. Now let's see what are the major responsibility of this checkout backend service, because from here the actual system or the actual drama starts. So let's first see what are the responsibility of this checkout backend service and how it will perform. So the main responsibility of this checkout payment service is we have to first check that whether the session actually exists or not, because it might can happen that some fraudster comes into our system and try to do some hacking into our system. So we have to first check whether the request that had landed into our backend service, whether that request is a valid one or not. So we have to first check whether the session exists or not. Number two, whether the session have expired or not. So it might can happen that the session was created but it got expired, because as I already told you, there will be a session timer that keeps on running in our checkout page, and that timer is nothing but the TTL that you have set for this Redis cache. Now, I hope you can correlate everything, that how the backend system is developed. So obviously, when you are inserting data into this Redis cluster, obviously, since it is a short-lived data, so you have to put a TTL in our backend, and that TTL is nothing but a session of 10 minutes, and that information of 10 minutes is actually displayed on the web page that we are showing to the user by this front-end checkout service. So obviously, in the response of this checkout session service, we also have to send some other metadata like what is the time limit of the session and all those things. I hope this is clear. So the TTL that we are sending from this checkout session service is actually our indicator that whether our session got expired or not. And after that, we have to do one more thing, and that is we also have to check that the payment intent which we have received over here, whether it is a valid one or not. So from this checkout backend service, there will be multiple validation calls that will go across our system. So the first request will go into our Redis cache for the validation. So as I already told you, Redis cache will have all the information like what is the payment intent ID, what is the session ID, who is the merchant, what is the order ID, and all those information. And if all those things matches with the session request that we have received right now, then only we can tell that the request that we have received on the click of the pay is valid one. Clear? And if the request is valid, then we will go into our next step. That is, we will go in the tokenization service. So obviously the data what we have received over here, that is the sensitive data of the card and everything, which we cannot store into our system, as well as we cannot transfer that data directly to some external agent, that is our processor service. because it have to be a PCI DSS complaint, and this complaints or standard tells that we have to encrypt or tokenize this card details. So what we will do here, before making this processor call, we have to make another internal call, and that is within our tokenization system, which is itself a secure and a PCI zone where all the tokenization is done. So let me first draw that thing. After that, I will let you know how the things are actually working over here. So this is how the tokenization system actually looks like. So let me just go through this one by one so that it will be clear to you that how the things are working beneath the system. So what is actually happening, once we have validated that a particular request is valid and authorized, what we have to do, the first thing is we have to tokenize the card detail, and for that we are calling a particular service in our application that is called a tokenization service, which is totally a secure service, or we can call it a PCI zone, where all the credit card related transaction or encryption actually takes place. So let's see what are the things that are there in this PCI zone. So the first service that we are having over here is called as the tokenized service. So what this service is actually doing, the first one is like, once it receives the card number, it first do a validation that whether the card number is valid or not. Then if the card number is valid, thereafter what it does, it generates a fingerprints for this card, which comprises of the BIN number, the last 4 digits of the card, the expiration date, and the name that is written on the card. So just combining all this information, and thereafter by producing a hash of it, it actually creates a fingerprint of that card, so that in the future it cannot be decrypted if in case it gets stolen. Now what is a BIN number? So if you just see the information that we have in a credit card, so you will get to know that a credit card will be having a 16-digit ID, and the first 6 characters that we have is actually the BIN number, which is nothing but the bank identification number, that whether the card belongs to ICICI Bank, whether it belongs to some different bank. So it is basically the identification number of the bank. So this first 6 number it actually captures, and then thereafter it takes the last 4 digit, means this one 3456. Then it takes the expiration date of the card and the name that is written on the card, and just combining all these things and creating a hash of it, it basically create a fingerprint. Now once the fingerprint have been generated for a particular card, then we have to encrypt that card also. And to encrypt a particular card, what we need a key for that encryption. So normally what we do in a normal encryption way, we keep the encryption key in some server or some storage unit, maybe a private key or a public key, whatever it is, we have to store that key somewhere. But in the case of the bank or in the case of the credit card, we do not have a private key or a public key to encrypt, because whatever you are storing in some cloud or in some storage unit, that can be stolen. But to do this even more securely, what we do, we take the help of a hardware service which is called as a HSM, means hardware security module. So I will just request you, just check the Google that what is the hardware security module. So here you can see the third step is like encrypting the PAN using the hardware security module. So here the PAN does not mean that what we have or the Aadhaar or that identification number, rather this is nothing but the card numbers or the fingerprint that we have generated in our previous step. So here with the help of these 3 steps, here you can see we are completely securing the data of the card, so that we can thereafter transfer that encrypted card details into some different system. So once this validation of the card, encryption and everything is done, what we do, in the response to this request, we send the encrypted card token in the response. So the response of this service will be the encrypted card token. I hope this is now clear that what we are actually doing within this PCI zone. And obviously one more important thing that you have to remember, that this request is not a HTTP request, rather it is a TLS connection, which is much more secure than our HTTP or HTTPS solution. So this is how a particular card gets encrypted in a payment gateway. Clear? Now once the card details get encrypted, Thereafter comes the main thing, that is we have to send this data to our payment processor. Now what happens is like once this checkout backend service receives this encrypted token ID, it have to make the final call, and that is to the processor which can actually process the data with the bank. But before this also there is one more important step, and that is by which processor the request should go. Whether it should go with the Rupee processor, whether it should go with the Razorpay processor, or whatsoever, means who will actually talk to the bank and how it is done. This is actually configured by the merchant during the onboarding process. So here if you see, here we are having the merchant, and when they have onboarded into our payment gateway service, they have also registered one more thing, that which processor they want to choose for their successful payment, because the charge for a particular transaction depends on the processor. So for example, some processor takes 1% charge, some takes 2% charge. So based on those lines or based on some other data also, this merchant or the client will take the call that which processor they should talk to. And for that, based on the configuration that they have set to divert the request to that processor, what we have to do, here we have to do something else. That is, once the checkout backend service receives this card token, it will call a simple service called as a orchestrator service. So here what I will do, I will introduce a service called as a orchestrator service. And this orchestrator service will first check the configuration of the merchant, means whether the merchant have chosen the PayU processor or the Razorpay processor, or based on that it have to diverse the traffic accordingly. So here what it will do, the first thing is like this orchestrator service will first talk to a database that is nothing but merchant preference database. So here we will be having one more database called as the merchant preference DB, which will simply hold the information that for a particular merchant, is for example Amazon will want to go with the Razorpay system. Based on that, the mapping object will be present in this merchant preference DB. Clear? And based on that merchant preference, what we have to do, we have to diverse the traffic accordingly. Means we have to call our processor accordingly. And to do so, what we have to do, we have to create our processor request, and it is quite obvious that the request body of different processor will be different, and for that we have to go with our adapted design pattern. So let me just draw that design pattern over here. After that I will let you know how the things are working over here. So here if you see what is happening, as the request comes to our orchestrator engine, what it will do, it will first check the preference DB, that is the merchant preference DB, that which processor it will send the data. And based on that, this orchestrator service will forward the data or forward that request to that following connector service. So here, for example, this Razorpay connector service is only responsible to call the Razorpay system or the Razorpay processor. Similarly, the PayU connector service is only responsible to call the PayU processor. Clear? So right now what will happen, they will make the final call, and that is to the processor who will be actually making the payment. So here we will be having some backend processor which are nothing but the FinServ, PayU and all those things. And to talk to this entire ecosystem, what we have to do, here will be a processor gateway by which we will be able to talk to this backend processor. So here we will be having our next thing, that is our processor gateway, which is completely an external agent. So until this point, this is our system. This is completely out of scope of our design. But I'm just telling you that from here, from this, it will call the processor gateway, and from this processor gateway, it will internally call the processor service that they have configured at the backend. And this processor service will internally talk to the bank for all the transaction that is doing. Clear? Let me just draw all these things over here so that it will be easy for you to understand. So here this is our processor system, which is an external entity. Now, if you look carefully, we have already sent the request to the processor, but we need a confirmation from this processor that whether the payment was successful or not, or the payment had happened to the bank or not. So in the response of this request, what it actually happens, here we have to introduce one more service which will be responsible to get the response from this processor. So I hope you understand that here we are sending the request, But since it is an external agent, we cannot expect that on a 0th second we will get a response. So here we cannot get a response in this request. Rather, there is a callback function or a callback service that is responsible to get all the response of this request. So for that, here we have to create another service called as collector callback service. You can name it anything you like. So here this is our service, which is collector callback service, which will receive all the response from the processor service. Now, obviously, here there will be thousands and thousands of requests or response that it will receive. And once we receive all the status message, what we have to do, we have to obviously update the database whether the pay request was success or fail. Clear? But here if you just look carefully, I have missed one important thing, and that is here this orchestrator service, before making the call to these processors that we have over here, it does one more thing, and that is it saves the information of the payment before going to the processor service. So here we will be having one more database called as a payment transaction DB, which is actually the core database where all the transaction history or the transaction status are actually getting saved. So here we will be having our main database called as a payment processor DB, which will act as our persistent storage unit for all the transactions that had happened through our gateway service. Clear? So here we will be having another database called as a payment processor DB, and obviously this will be an RDBMS database, and let's see how the schema structure will look like. So this is how the schema structure of the payment processor will look like. There will be thousands and thousands of other information also here, but these are the most important thing that we have to say. That is the transaction ID, intent ID, status, amount, currency, merchant ID, and all those details. Now, as I was telling you, once the requests have been made to the processor unit and we get a response into our callback service, what we have to do? Based on the response, we have to actually update this database. Means here if you look carefully, we have a field called as a status. Means once the requests have been sent by the orchestrator service into the processor, what it does, it will mark this request as sent. Now once we receive a response from this processor service into our callback service, what we have to do, we have to update this status service. And who will do it? Obviously it will be done by the single service, and that is the orchestrator service. So these orchestrator service have a major role in updating the status over here, because if some other service update the status service, there can be a duplication or there can be an inconsistency within our database. So it is the responsibility of this orchestrator service to update the status field over here. That is, the requests have been sent to the processor and the processor have given the response that the order have been placed to the bank. So the status will be marked as done. Clear? So a particular request that have come from the user have been placed successfully to the bank, and right now we have a status called as done. But now the question is how we will send this acknowledgement to our front end, that is nothing but our payment checkout front end, which is nothing but this web page that we have created for the user. Now let's see how it is done. So this front end service actually calls this checkout backend service beneath the system. So it actually pulls the data for a particular transaction request. So for example, once the user clicks on pay, it first sends the data to this backend service, and it keeps on polling for that particular request, that whether the status of that request got changed or not. If it got changed to success, it will show the user that it got successfully placed. Otherwise, it will show it as failed. So this checkout backend service also have to do one more thing. That is, here this checkout backend service have to see the status of the particular request in this payment processor DB to see whether the status of this request have been changed to success or failed. Clear? So this is how this entire processing unit or entire transaction actually takes place in the bank. Now there is one more important thing that you have to know. That is, the request that we have placed to the processor right now is not the final confirmation that the money got deducted from the bank or not. It is just like the request have been placed to the bank. It might can happen that the transaction will get failed if you do not have the sufficient balance, or some other credential can also fail. And for that, what we have to do, there should be a reconciliation job that will run after 1 day or 2 day, which will actually tally this transaction request with the response that is sent by the processor. And based on that tally, we have to confirm the client that the particular transaction got successfully done in the backend. And that is why, if you have seen that if a particular transaction fails on Amazon, also if you go and reach their customer service, they will tell you that in case your money got deducted, we will refund you, or it will get updated after 3 to 4 days. That 3 to 4 days is nothing but the reconciliation time that it takes for all the data that we have collected to validate and reconcile. And to implement that, here what you have to do, here if you look carefully, I have intentionally done one thing. That is, I have shown that this Orchestrator service is directly talking to this callback service. But actually, in real life, it cannot be like that. Rather, what we have to do, here we have to go with an event-driven service. Means here, once this callback service receives the data of the status of a particular transaction, it will put all the status in a Kafka broker or in a particular buffer. So here I will put a Kafka broker or introduce a Kafka broker, and this Kafka broker will have few of the topics. So let me list down all the topics that we have over here. So this Kafka broker will have two topics. Number one, the payment processor callback status, means whatever the request we have sent to the processor, all the status will come immediately into this topic, that is in the callback status topic. Now, once the data is there in this topic, this collector service will act as a consumer, and instead of this reading it from this callback service, it will actually read from this Kafka topic. Clear? So here we can see we are using a PubSub design pattern. Means once the data is there in this topic, this Orchestrator service will simply read it from this Kafka and it will update that payment over here. Now, after a day or so, once the final confirmation is done with the bank, this processor service will again send an acknowledgement of each and every transaction to this collector payment service, and it will send it to another topic called as a payment processor status, which have the data of 1 day delay. Means it is not the immediate data but the data which comes after 1 day. And this status have the final confirmation that whether the payment was successful or not. Now we have to do the final reconciliation, and for that what we have to do, here we have to create one more service called as a reconcile service. And this reconciliation service will talk to this Kafka broker and will update the database that we have over here, that is the payment processor DB, into some different tables. It is not that it will update the same table, rather it will be a separate ledger table which have the final information of the payment, means who have done the payment, what is the timestamp on which the payment was done, and all this information will be there on the last table of this entire ecosystem called as a payment table. Clear? So here if you look carefully, I have almost covered everything that is required to design a payment gateway ecosystem. So I hope you have thoroughly understood this video and you have found this video useful, and I hope you have completely got the clear idea that how each and every function are doing the validation, authorization, tokenization, and how the data is getting PCI compliant and how it is getting transferred from one service to another. And if you have understood it and if you have found this video useful, do not forget to like, share and subscribe to my channel and hit the bell icon so that you never miss an update from my channel and you are always ready for your next interview. So see you in our next video where we'll be solving another problem from our system designing interview. So see you in our next video.